Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter System of Particles and Rotational Motion. So uh, any doubts if you have in any steps, then please write that in the comment section. We shall obviously clarify them in the subsequent videos, and in any other chapter of physics, if you feel more difficulty, then also mention the name of that chapter in the comment section, so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions will be uploaded in the Sapience Education application, whose link has been provided in the description. So here it has been told that in figure E and VCM represent the total energy and speed of the center of mass of an object of mass 1 kg in pure rolling. The object is, so we know that if an object is under pure rolling, then VCM is the speed of the center of mass, and if E is the total kinetic energy, so then it will be the rotational kinetic energy, which is half I omega square, plus the translational kinetic energy, which is half m VCM square, if m is the mass of the object. And I can be written as m k square, and omega is obviously v by r. Since why there is, it is pure rolling. For pure rolling, we can tell v is equal to r omega, since the point of contact is at rest with respect to the ground. So therefore, I can write this as half mk square into v square by r square plus half mvcm square. So, and this is also vcm by r. Omega is vcm by r. So this from there, half mvcm square I can take as common, and then I can write 1 plus k square by r square. Now here the mass m is 1. And here we can see that the slope means E is equal to 3 joule. The total energy is 3 joule when the value of VCM square is 4 meter square per second square. So with this, and the mass is given as 1 kg. So from here we can find out how much is k square by r square. So therefore we can see that 3 will be equal to half into 1 into 4 into 1 plus k square by r square. So 2 to the 4. So therefore 1 plus k square by r square, that is equal to 3 by 2. So therefore k square by r square will be equal to 1 by 2. So k square is equal to r square by 2. So therefore the moment of inertia, which is mk square, so that can be written as mr square by 2. So mr square by 2 is not for sphere, not for ring. So it is for, and it is not for hollow cylinder also. So it is for a circular disk only. So for disk, the moment of inertia is mr square by 2. So option C is the correct answer. Then here it is told the angular speed of a motor wheel is increased from 120 means 1200 rpm to 3120 rpm in 16 seconds. The angular acceleration of the motor wheel is, so angular acceleration we can tell it is omega final minus omega initial by the time interval. Here the final angular speed is 1200 rotations per minute. RPM full form is revolutions per minute. Revolutions per minute is RPM. So 1 RPM means that in 1 minute it will cover 2 pi radians. So it is 2 pi radian in 1 minute means in 60 seconds. So it means it is pi by 30 radian per second. Pi by 30 radian per second means 1 RPM. So therefore We can tell it is 1200 into pi by 30 radian per second. So simply, therefore, alpha will be equal to omega final is 31, sorry, this is omega initial. So omega final is 3120 RPM minus 1200 RPM into pi by 30 I will do, divided by 16 seconds. So then this will come in radian per second square. So therefore it will be equal to 3120. So this will be 0 2, then 9, then 1920 by 16 into pi by 30 radian per second square. So this will be 0 cancel. So then 3 is 18, 3 4 is 12, 16 4 is 64. So 4 pi radian per second square. 4 pi radian per second square is the required angular acceleration of the wheel. So option D is the correct answer. Then it is told the center of mass of an extended body on the surface of the earth, extended body on the surface of the earth, and its center of gravity will coincide only if the size of the object is negligible as compared to the size of the earth. It means if and only if the size of the body is much less than the radius of earth, then only we can say that, then only the center of mass coincides with the center of gravity. Coincides with the center of gravity. So option C is the correct answer. The center of mass coincides with the center of gravity of a body if the size of the body is negligible as compared to the size or radius of the earth. Then here it is told that 7 identical uh, uh, disks are arranged in a planar pattern. 7 identical circular disks are there. 7 identical circular disks are arranged in a planar pattern so as to touch each other as shown in the figure. Each disk has mass m and radius r. So what is the moment of inertia of the system of 6 disks about an axis passing through the center of the central disk and normal to plane of all the disks? So here we can see that uh, the mass of each of the disks is m only, and each of them has got radius r. So as we know that moment of inertia of a circular disk through its center of mass is mr square by 2. We know that moment of inertia of a circular disk about an axis through its center of mass and normal to the plane of the disk and perpendicular to the plane of the disk. It means if the disk is like this, then about this axis, the moment of inertia will be given as obviously mr square by 2 if its radius is r and its mass is m. The rule is that the moment of inertia of a uniform circular disk about an axis through its center of mass and perpendicular to its plane, means to the plane of the disk, perpendicular to the plane of the disk, that is given as mr square by 2. So here also about this axis, this will be mr square by 2, this also will be mr square by 2. So here we have to apply the parallel axis theorem. Since this length will be obviously this length L will be obviously 2r, twice of the radius. So therefore the net moment of inertia, therefore the net moment of inertia of the system, the net moment of inertia of this system of 7 circular disks of this system of 7 circular disks, that will be equal to, means I1 for the central disk, it will be mr square by 2 only, since the axis is passing through its center of mass only. So it will be mr square by 2 plus 7 into I1 plus ml square actually, where I1 is actually mr square by 2 only. Since why? About this center, that will be mr square by 2. Means about this center, it will, for each of them, it will be mr square by 2 plus ml square. If we apply the parallel axis theorem, since according to the parallel axis theorem, we know that it is ICM plus MD square. So therefore it will be mr square by 2 plus, okay, mr square by 2 plus 7 into mr square by 2 plus ml square. L is 2r, so 2r whole square. So this will be mr square by 2 plus 7 mr square by 2 plus this is 7 into m into 4r square. So this will be obviously 7 by 2 plus half, that is 8 by 2, so 4 mr square. 4 mr square plus 28 mr square, which will be equal to 32 mr square. So this will be actually, okay. So here, okay, circular disk is there, mr square. System of 6 disks, about 7 identical disks, so as to touch each other. Each, what is the moment of inertia of a system of 6 disks about an axis passes the center of central disk and normal to plane of voltage? So here we have to find the moment of inertia not of these 7 disks, but only of this uh, of the 6 outer ones, of the 6 disks only. So we have to find only for the 6 disks, means only this one we have to find. There is something mistake here. Yeah. System of 6 disks, okay. So remaining there are 6 only. So 6 into, okay. So it will be 4 mr square plus mr square by 2. So this will be 2 for the 8, 9 mr square by 2 to 6. So okay, system of 6 disks. So this will be 6 into mr square by 2 plus 6 into m into 4r square. So this will be 2 3 are 6. So 3 mr square plus 24 mr square. So that will be 27 mr square. So it means that option C is the correct answer. And if we want to find for all the 7 disks, then with this we have to add one more mr square. Then it will be option A, which is 55 mr square by 2. Since why, if we add mr square by 2 with 27 mr square, then what we will get? We will get 55 mr square by 2. So then we will get option A. So option A will come if it was asked that what is the moment of inertia of the system of the 7, all the 7 disks. Okay. Means moment of inertia of the system of all the 7 circular disks, that will be 55 mr square by 2, and the moment of inertia of only the outer 6 disks, that will be 27 mr square. So here, so thank you everyone. Hope all of you have understood the solutions of all these questions, and still any doubts if you have, then please write that in the comments section. We shall obviously clarify them in the subsequent videos, and also please install our Sapience education application, where we shall upload some important questions based on the previous year KCET exam. So thank you everyone. Bye.